Assalamu alaikum. In this video, we will explain the last objective of this chapter, radioactivity. The objective of this video are to define activity as well as the half-life of radioactive element. In the previous video, we have discussed the type of decays. We have seen that alpha decay takes place when a helium particle is emitted and it is positively charged, and also it has low penetrating power. Also, we have discussed the beta minus decay, and such kind of decay takes place when an electron is emitted. It is negatively charged and it has average penetrating power. Beta plus decay is also discussed, and it takes place when a positron is emitted and it is positively charged and it has average penetrating power. The last type of decay that has been discussed was gamma. It takes place when a daughter nucleus is de-excited from high energy level to low one. It is electromagnetic radiation, massless, uncharged, and it has high penetrating power. Each radio element is characterized by its half-life. And to understand this concept, we should understand the concept of activity. Let's discuss the following example. We have a radium nucleus, is an alpha type decay. It disintegrates into radon and helium. In this sample, we donate the radium nucleus by blue and the radon nucleus by red. We can see how the number of radium nuclei decreases exponentially while the number of radon nuclei increases also exponentially. The rate of variation of the number of disintegration of the nuclei is defined as activity. So, activity of a sample of radioactive matter is the number of unstable atomic nuclei that decay per second in a given sample. The unit of the activity is expressed in becquerel, and there is another unit called curie. To convert from curie to becquerel and vice versa, we use 1 Ci is equal to 3.7 times 10 power 10 becquerel. As you have seen that in radioactivity, a nucleide X will be transformed into another nucleide Y with another physical and chemical properties. So, if we have an amount of a nuclei X, what is the time evolution of this quantity to be transformed totally or partially into Y? Is it arbitrary evolution? Of course, no. The radio element evolution is controlled by the nature. To understand this evolution, we have first to understand the half-life of a radio element, which is a specific interval of time for each radio element. It is one of the natural properties of the element. Regarding to this animation, half-life is the time taken by the radioactive sample to decay half its initial value. For example, in this animation we have here 10 red particles and 5 of them is decayed into blue particles. The time taken by these 5 red particles to decay into 5 blue is called half-life or period. We can determine the half-life graphically. It is the abscissa of the ordinate that has value equal to the half of its initial quantity. We can see that after first period, the initial amount is reduced to half. It was 100 and it become 50. And after another period, the quantity become to 25. And after another period, the quantity become to 12.5 and so on. To more understand this concept, let's discuss the following case. The adjacent graph represents the number of nuclei of radioactive element versus time. Initially, the number of nuclei is n0, and after one period, the remaining number become n0 over 2. After next period, or 2 period with respect to the initial value, the remaining number of nuclei is n0 over 4. After 3 period, the remaining nuclei are n0 over 8. To generalize a rule and to determine the remaining number of nuclei at time t equal n period, we can use the relation n equal n0 over 2 power n. where n is the number of decay and t equal nt represent the age of the sample. The graph of variation of the mass or the activity of radioactive nuclei versus time is resampled to the curve of variation of the number of nuclei of the radioactive element versus time. All decreases exponentially versus time. Also, we can determine the half-life graphically from each curve. It is the abscissa of the ordinate that has value equal to the half of its initial quantity. In this table, we present some half-lives of different radioactive elements. As shown, the radioactive element of polonium nucleus is very small, however, the half-life of the plutonium nucleus is very long. So we can say that each radio element has its own half-life. To practice, let's solve the following application. The period of iodine 131 is 8.1 days. This nucleide is transformed into xenon of mass number 131. In the first question, we have to determine the type of radioactivity of the iodine nucleide. So first, we have to write the equation of decay. The iodine 131 is decayed into xenon 131 plus particle of unknown mass number and the charge number. If we know this particle, we can know the type of decay. We apply the law of conservation for mass number and the charge number. We get Z equal to -1 and A is equal to 0. So the emitted particle is electron since it has negative charge and 0 mass number. So the type of the decay is beta minus. In the second question, we have to calculate the mass of the iodine after 3 periods, knowing that its initial mass is 80 grams. After first period, the remained mass is 4 because 8 divided by 2 gives 40 grams. And after second period, the remained mass is 2 because 4 divided by 2 gives 2 grams. And after t equals 3 periods, the remained mass is 1 gram because 2 over 2 gives 1 gram. Or we can calculate it directly using the relation m0 over 2 power n. In this case, n is equal to 3. So the remained mass is 8 over 2 power 3. It gives 8 over 8, which is equal to 1 gram. The last question asks us to determine the disintegrated mass of iodine, or in other meaning, the mass of the form xenon. The answer is simple. We know that from the previous part that the remained mass of the iodine is 1 gram, and initially it was 80 grams. So the disintegrated mass is 8 minus 1, that gives 7 grams. At the end of this chapter, we have seen that radioactivity is a spontaneous reaction. Radioactivity transforms radio element into more stable one. In radioactivity, the mass and the charge number are conserved. There are 4 types of decay: alpha, beta minus, beta plus, and gamma. Each radio element has its own half-life. Period is the time taken by the radioactive element to decay the half of its initial quantity. Its SI unit is second. Activity is the number of disintegration per second. Its SI unit is Becquerel. Please watch this video many times and contact your teacher for any further information. Wassalamu alaikum wa rahmatullahi wa barakatuh.